Howdy, everybody. Hope you're doing well wherever, whenever you are. Um, Today was a fun day, I think. Um, I think my solution is going to look a little funky until you see part two, and then it will make more sense. Um, but we'll step through it and kind of look at it. Um, anyway, I love looking at your solutions. Please send me yours. I'm getting lots of positive feedback, which is good. You know, the goal of the channel, I think, is to help us all learn and grow, including myself. So we'll just keep pressing forward and see if we can't do that. So what does day 6 look like for Advent to Code 2025? Did I not say that? That's what we're doing. Um, Sorry, it's been a weird morning. So the idea between, so what happens in the day? You fix the kitchen, right, the day before, and you're reenacting a movie scene, and you accidentally jump in the garbage chute. I don't know if that's a reference to Star Wars or something else more modern. Anyway, while you're stuck in there, you find a group of cephalopods and you tell them you'll help them do their homework. Their homework is, or their math is a little bit different though. You only have to worry about add and multiply. And I think that's key to a couple parts because you don't have to, left to right and right to left don't really matter, right? In that sense. So, but what they do is they give you these values right here. And they want you to do the addition or multiplication vertically and then sum up the results going this way. So like that's to say, at least for part 1, what they want you to do is like do this block, and this block, and then this block, and then add them all together. Okay, and that's it for part 1. So that's the day, I guess that's what it's asking you. My actual solution for part 1, like you okay, so I should say my initial solution for part 1 was pretty simple, right? You can just split these by white space and then you just enumerate over the values going this way, right? So you think you just take a vertical slice. You now have like 4 arrays. Maybe the way to think about it is you now have 4 arrays or 4 vectors, like right here, right here, right here, and right here. And if you just go over the indexes and you just say, okay, for if I'm multiplying, I do this times this times this, that gives me this one, and I sum those all up. My solution doesn't look like that because part 2 looks a little bit different. So I'm gonna I'll show you more aligned with like what my actual solution was. And the actual solution was to actually think about it like this. Can I just get a block like this? So if you give me this thing, can I figure out what the block is? And it turns out that that's actually not too hard. I think there's 2 major ways to do it, right? Is you could either look for these like empty spaces right here and then split by where the whole block is empty. The one issue that I ran into is like there's no empty space right here, right? So I suppose you could add an empty space at the end of each of the lines. The other thing you can do, which is what I ended up doing, is you can like look at the operator row, right? So if you consider like this position right here and then this position right here, these all signal like the beginning of a block. And so the end of the block is really just you say, hey, where's the next operator? And then I know the end of my block is right here. So like what it ends up forming is like the block is here to here, and then here to here, and then here to here, and then here to. So this, it seems a little excessive for this particular problem. But if you look at, or for the example, I guess I should say, if you look at this input though, you can see that like this first block is 4 characters wide, right? I guess 5 with the space. This one's only 2 or 3 with the space, and this one's 3. like this is all to say like they're different sizes, and so it kind of doesn't make sense to like, or it makes more sense to say just find the next position and grab the block. Like if you were to just say if they were always 4 sizes, you could just like chunk by 4 and go through. Anyway, so that's the point of this, is to say, okay, can I get this block? And now once I have this block, I just need to ask myself, like, how do I turn the block into the number, right? And so I'm going to create a mapper function that where you give me the block, and I will return a vec a size. Okay, that looks okay. But that's what I'm going to return. So you give me this block, and I'll give you 1, 2, 3, 4, 5, 6. At least for part 1, right? 1, 2, 3, 4, 5, and 6, and then you can just do your operator on it, sum or multiply. So let's look at that in code. First, I have my operator. I'm doing bytes, so notice I, instead of including stir, I include bytes. I think this was helpful for doing some slicing that you'll see in a little bit later. So that's why I moved. I think it made it more readable. Anyway, so we have our operator say, hey, can I get an operator from a U8? Sure. If it's a asterisk, we do multiply. Otherwise, we assume it's add. Again, I'm not doing any unwrapping or checking. I get comments occasionally in like my YouTube shorts about like, aha, unwrap. And yeah, you know, we're solving puzzles, so we unwrap a lot. Do not unwrap in production code, especially if you work for a company as big as Cloudflare. Okay, so what do we do? Here's my chunk operators, right? So if you give me the operator line, I'm going to return an iterator that's going to give you like the block of the operator, right? So that's going to return like this piece right here. Going to return that entire block. And that's helpful because then I can, like, for the rest of it, I can just expand it upwards, right? Like that. Like that's the goal. But the first thing is, you know, give me this block operator. And I was not aware of this standard from FN. At first, I was just returning a vec of like the values, which I think is totally fine. But I like the idea of like how many ways can you return an impl iterator. There's actually a way down below, I'll show you later, that I couldn't figure out. But anyway, you can do this from FN, and basically what you do with the from FN is you think about it as like a Python generator function where you like yield values until you're done. It's the same thing right here, is like we're going to yield a chunk until there's nothing left to do, and then we return none, and we know that, and then it will know the iterator's done. So this is going to wrap my function in an iterator. What does that function do? Well, we start with the entire string of the operator list, that line, and then we just say from where I'm at, where is my next operator? And that's just where it's not a space, right? And I get that index. If I'm at the end, I want to return the remainder.lane, right? So that's why I unwrap or remainder.lane. So this is going to have the effect of getting me, but you can see here I was trying to get the AI to help me with, I'll show you later. I couldn't figure it out. I couldn't get the AI to help me. But so what do? Is you say, you know, if I'm here, find the next position. So like find this one. It's going to skip all the spaces and find this one. And now I'm going to update my remainder to be right here, but I'm going to yield back this block right here, right? Well, it's just this block right here, right? Like the operator. So my chunk that I'm going to return is my remainder to the end, and then the remainder is the you know, the end to the thing. I guess I can call it. Enumerate, skip, find, map. Yep. Okay, that's what I'm doing. I was just double checking. Okay. So now that's going to get me each of my my operator sizes, right? Well, now I can wrap that in a parse function, right? What does this parse function do? You give me the entire grid as a U8, right? So it's just a blob of strings, right? It's the literal include bytes of the input. And you give me the mapper function that I talked about. And what is the mapper function? It says if I give you a sub slice of the grid, give me back the vec u size. So what that has, again, what that has the effect of doing is I'm going to create this. I'm going to give you this, and I want you to turn that into the numbers, right? So it may be, in this case, 64, 23, and 3. Like, that's what I want you to give me back. And this will be more important in part 2, but so I'll show you how that works. First, we take the thing and we turn it into a bunch of lines. We do line is not empty because there's actually a new line at the end of the file. So now we know the last line is the operators and the rest of the lines are the numbers. So we call our chunk operator on the last one, and then we're going to do a scan. Remember, scan allows us to track an accumulator, but yield values through it. So it's going to spit out values through it. So how do we do that? Well, we're going to start at 0, and then you're going to give me the operator block from chunk up operators, right? And now we're just going to go through all of the values but the last one. So these are like the numbers in the grid. We're going to iterate over them. We're going to return a slice of those values and collect them into a vec. So this is going to give us our sub slice. Like, these numbers is this part right here that we're looking at, right? The 64, 23, 14 with the spaces. And so now we just update our accumulator. So our cur, we now increment it by our length. We create our operator and we return the result of our mapper for that block of numbers and the operator to use. So our parse function, this is a lot of talking, I'm sorry, but our parse function is essentially returning the block of u sizes and the operator to perform on them. Okay. So how does the P1 mapper look? You're gonna give me a block, and I'm just going to iterate over the block, and I'm going to the way that I'm going to mutate it is I'm going to trim all the spaces and then do this fold, which is like turning the bytes into their equivalent numbers. And the way you do that is you say multiply the accumulator by 10 and then add the current digit that we have. So we start at 0. 0 times 10 is 0. We add our first digit. So this is b minus the character 0. That will give us the literal value. We've seen this before, right? I presume in other code. I don't always do it this way, but I thought the U8s would make more sense in this specific case. I don't know. You'll have to tell me how you think about it. I waffle between should I just do a vec car, stuff like that. This one made more sense because maybe the way I should describe it is when you're doing this, you kind of want this block right here. And like, are you interested in like the strings of these or not? I don't know. It kind of felt like I'm just interested in the bytes of them, and so it made sense to kind of do it this way. Again, so just our mapper is we're doing the horizontal value, right? So we're going through our block, we're iterating over each of the lines, right? And then we're just doing this math to turn it into a number. So then what do we do for P1? Well, we just say call parse on the input with our P1 mapper, and then we just have to map that to give me the numbers and give me the operation. So if it's add, I sum them. If it's mul, I do the product. I don't know why I have to do this sum right here. If you look, like if I try and do this, it doesn't work. But I don't have to do it for product. I don't know why that is. It's possible that product defaults to some value. Anyway, there you go. That's part one. This is not my original solution to part one. My original solution was just make 4 vec's of numbers, and then make the last one a vec of operators, and then just go down through, and it's all pretty fast. It doesn't solve as fast as this. I suspect you could get this faster because I couldn't figure out how to not use vecs here in my mappers, and I'll show you that in like later. But anyway, so let's talk about what happens in part 2. Part 2 says, oh, you did the math so cool, it's actually wrong. They read right to left, which it turns out doesn't matter, but they also read top down, where the top is the most significant digit. And so that is to say, this problem now becomes 1 times 24 times 356. This last one is 4 times 431, or plus 431 plus 623. So you're still operating in the blocks, you're just doing it vertical now, right? So when I yield, or like when I yield back a chunk like this one now, what I am really interested in doing is like making the numbers from like these right here, right? And that's, now you can see hopefully why I use the mapper, because the mapper is different, right? So I can still use this mapper function, but now I just want to map differently. I want to map vertical here versus horizontal up here. That makes sense. So like that's my goal. That's what's happening in part 2. Well, we've already done all the talk about like, okay, yield our chunks or create an iterator for our chunks, have our parser create an iterator where you give me a mapper and then I'll turn it into the thing. So all we have to do for part 2 is make a mapper, right? So we have a make vertical number. This is just a helper function that I wrote, and you give me the block and the index, like the value going this way, and I'll turn it into a number. And the math is the same. Again, you do the accumulator times 10 plus the, this minus b minus the 0 value of byte value of 0. And then that's going to give you the thing. But now instead of doing it horizontally, you're now doing it vertically, right? So I go through all the values and I do v of index. So I'm going to get like all of the zeros, the ones, the twos, the threes, so on. So what does my mapper look like? Well, if you give me a block, I'm going to filter where all of them are blank. Again, remember the last one is blank. Before we could trim end, but now we can't really do that. I couldn't find an easy way to do this. Again, I suspect if you like just append a space and then always shift minus, it would also work. It's also easier just to filter, right? Obviously, we don't want to return a number where they're all blank because the number would be 0, which is not a big deal for addition, but it is a big deal for multiplication. So, anyway, we filter by that, but then we can just call make vertical number for each of the values or for each of the columns indexes, right? So we have a value for each of the column indexes and we sum them up and that gets our thing. And then it essentially looks identical to part 1, but now we're just using our vertical mapper, our P2 mapper, as opposed to our, and that solves it. Okay, so before we finish with part 2, I kind of want to talk about like what I was trying to do here with the AI. I still don't know how to do this. So if there's a smarter Rust person out here, I would love to hear how you might fix this to make it work. The idea is, the issue that I was having was with like understanding lifetimes. And so if you think about what this parse function is doing, is it's saying you give me a function, I'm going to return an iterator, and that iterator is like based off of the input right here, this reference, but it actually isn't. There's nothing in here specifically that says I come from this, right? Like normally if it was you give me a string and I'll return a slice of that string or some part of that string, the the Rust borrow checker will figure it out automatically, but you can actually put in there, you can say, oh, the lifetime of the string is equal to the lifetime of this. And you, as far as I know, you can do that here, right? So we could say, we could create a lifetime where we say this has a lifetime, and we could say this has a lifetime as well that comes from this thing right here. I think there's like a for thing, a for lifetime, where you can say the lifetime is for something. And that's what I think the AI was trying to do here for a little bit. Let's see. Where is that? I tried to coerce it quite a bit. Maybe not. Oh, it's these pluses where you say like this iterator has the same lifetime as A. So you do this plus A. And that actually works up here. But the problem is the lifetime, at least I couldn't figure out how to, or the AI could not figure out how to get that to apply to the mapper as well. So you have a lifetime A up here, and but you want like that lifetime to translate to this function as well, and I couldn't ever get it to work. So I suspect this is all to say I suspect my time here could be like halved, because you see I have to do like some collecting of like these blocks, and then I have to pass them here, and then I have to collect here where I to return a vector. If I could say just give me an iterator over u8s and give me an iterator over this, I suspect I could make it better. But I don't know how much. We're still solving it in microseconds, so I don't feel too bad. This is all to say is I spent quite a bit of time trying to impl iterators all the way through the thing. It doesn't make complete sense in part 2 though, because this mapper, you kind of have to look at all the iterators, all the values, and so you actually don't want an iterator over the outer. You'd have to collect it anyway. But it would be nice if you could return an iterator here where you don't have to worry about it. Again, I think this is like, I don't know, min-maxing a little bit, which is fun. It's fun to min-max the stuff. But there you go. There's my solution to part 2. And again, like the part 2 problem really changed how I did part 1. I don't know. Maybe the next time I do something like this, I can try and keep my original part 1 around and then do it different for part 2 and show you like the difference. But I suspect it's relatively easy to do part 1, or it's relatively easy to understand how I did part 1. Whereas you just create a bunch of a vec of ints, and then you just like go along the columns of the thing, and you know that solves it. So there you go. That was my solution to day 6. I don't think it was terribly hard. I mean, if you look the code, I have 100 lines of code, and it's probably a little verbose. I don't know that you needed to have an operator in here. Yeah, I don't know that you need to have an operator in here, but it was kind of, I mean, it was kind of helpful because I could do match expressions down here. Again, you could probably just match on the actual character here. So that's, 20 or 30 lines that aren't necessary. It depends how rusty you want to be, I guess. I did like learning about this from FN. This was kind of new. I kind of Google AI checked it. Like I was like, hey, I have this loop. Is there any way for me to turn? At first, it was just returning a vec of u side, or a vec of u8s or whatever. and I was like, hey, can I sorry, it was a vec of U8. Yeah. And I was like, is there any way for me to unwrap or wrap this loop into an iterator? I couldn't think of how to like scan correctly to get the things. Because if you think the way like a normal iterator works is like you need to have like some start value, some like thing that you're iterating over. And I couldn't figure out what I'm iterating over there. So this from FN is kind of cool. It allows you to like basically take a while loop. Again, I think I said this before. It works a lot like Python generators. You just yield your function, or you yield values to the function till you're done, and then you return done, and it knows to stop asking. So anyway, I thought that was pretty cool. Maybe let's go look at some solutions before we start looking here. Basic, surely the spaces are meaningless, right? C input, C inconsistent white space, decide to get rid of all excessive white space. Yeah. I did have some issues with that, right? And in particular, it doesn't show, like it does show here. Well, I think it kind of does, maybe more in the input. Like one of the issues you run into is like, where's one? This one, notice how like this is aligned differently than this one. Like this one is left aligned. How do I highlight this? This one is left aligned. And then this one is right aligned. So I had some weird issues with that. That's where it was easier to use Vex because I could like just give me, or the U8s, I mean, I'm like, just give me the blocks and I can just, as I'm going down columns, I can ignore. And as I'm going across, I can ignore. For some reason, the U8 felt cleaner to implement that way, but yeah. Wait, what is the subtle reference? Oh, Star Wars Trash Compactor. Yeah. Oh, is that the number of the 3263827? That's cool. Very cool. Okay. Day 7 part 2, brace yourself. Yep. Again, yeah, I actually don't think this day was this hard. I think you just struggle with like how to implement it. I imagine like as a speed solver, this day wasn't too bad because you're just like, naively like making specs, adding them, adding the value of the operations you do. And then you're just doing it the other way the next time. So I suspect speed solving isn't this hard. I overly engineered it. In fact, as I was doing it, I was like, man, am I overly engineering this thing? But I don't know. It was kind of fun to think about, oh, how do I return an iterator of the chunks and then use that to help me chunk the thing. Like that was going through my mind. In my mind, reading this top down, or like understanding the intuition seems like it makes more sense to me. But I can also see someone just saying, oh, I'm just going to take blocks of the thing and return it. The left right align. Oh, it did say that in the problem, huh? Sorry, I've got some kind of. Yeah, it's fair to be suspicious. That sign won't stop me. Cephalopod is right to left. In this case, it doesn't actually matter, right? Turned out better than it should have. Yeah, exactly. That sign won't stop me because I can't read. You can actually ignore this part, right? if it was doing subtraction, that would matter. Like, what is the problem saying? Is you actually want to read them from left to right. So you want to do for part 2, you want to do it order 4, 431, 623, and add across those, which is different if you're doing like subtraction or division. But in addition and multiplication, especially because you're multiplying the whole thing, it works either way and it doesn't matter. So that was something that I'm like, oh, right to left in columns, does that matter? No, probably. Parse the input only once. Yeah, this is a one that I suspect. So if you can see, I technically parse it twice. I guess I technically always parse both my inputs twice because I parse it for both solves. But usually you have like one way to parse both the parts. This does not work in this one. And so you can see my code looks a little, that's why I have that mapper function. It allows me to call a single function to do the parsing, but map it differently, which I think is a fun way to do it, right? Use some higher order function to do a mapping over those things. Help my son with his math homework. All the cool kids say. You are stuck in a trash compactor with, well, I stripped out all the spaces for part 1. Part 2. Okay. Each column is left justified. Yeah, this was the issue. I think I ran into this. No, yeah, I did. Because originally I was splitting. Oh, I was calling trim to trim off that last line, and that was messing up my numbers. Like, that was the issue I think I had. There you go. Another visualization. Oh, this is an interesting idea that might make it easier. Just start at the end and keep track of the numbers you have, and then when you hit an operator in that last row, you now perform the operation. This is a cool one. Might actually try and change this, not today, but to read. It. Back orders. I suspect this way will be faster to solve it than the way that I did it. I did it in kind of a funny way, and so I think it solves fast, but I don't write code for the problem, do it by hand. This is a funny one. I think you could solve most of this problem just in Excel, like with copy and pasting. Is that weird to like think that? Because in Excel you can do some really crazy, I guess Microsoft Excel, or maybe it doesn't work the same way in Google Sheets, but there's a way for you to do like importing raw text, and you can specify like, oh, do it columnar or whatever. He'll figure it out for you. Yeah. Oh, that can that what my test input failed too for this reason. Yeah, that's crazy. So when I paste and save, for some reason it trims the ends. It's something that I still haven't figured out a good way to like get the inputs, the test inputs. I think I mentioned this before. I think I'd like to create some way where I can like have a helper function that says save my test input, and then it puts it in there. It puts it in there. Huh. Okay. Look at the actual input before you start coding or draw it. Yep. I think this was another thing too. Like you kind of had to look at the input again because you have left and right aligned, and not all of them are exactly like. Here's the thing that had me going for a second. The input or the example has only 3 numbers, but the input, at least my input, has 4, and it does show the left and right aligned, I guess technically. Um, but that was something, yeah, I had to figure out too. Interesting. Uh, why is my answer negative? They are big numbers, right? I, I don't think that actually does. Okay, I got it. I think it was a Star Wars reference, so we got there. I don't. It does. The part 2 made it a little bit weirder. Very cool. 512 star. Part 1 eval. Okay, let's look at some actual solution. Rid of characters for part 2. Yeah, I think I technically use a grid, like what I was saying. Yeah, I mean, it is a grid, right? Basically, I'm creating a grid, and then I'm making blocks of those things. So what does this solution do? Okay, this is the +1 is like the cool way of like basically adding a space to the end. I don't think it will work as well in Rust, but in Python, just have the space. Uh, okay, so you're looking for a blank line. So you're basically moving along the columns until you get to a blank line, and then now you know. So he's blocking as well, or they're blocking as well. They're making a block. So once you have a block, here's your P1 solution, which is just left to right. Yeah, here's the problem times 10 plus the integer version of that. And then for part 2, I imagine it's up and down. Yeah, RC, but now you're doing C and R as opposed to R and C. Yep, so you're just like swapping whether you're going through columns or rows. Okay, yeah, very cool. Miser. This is an interesting way to index a 2D array, right? If you want to impl index, but you're interested in doing a 2D array, like how do you do that? There's not like an index 2D, I guess, the way to think about it. Um, so you say, oh, give me a tuple of the row column and I'll turn it into an index. Yeah, you're just getting the values from the grid. You get the leftmost value. You're going backwards. You get the leftmost value, and then you turn them into numbers. And I suspect down here you do the opposite. Okay, they use fold too. I like using fold to like get the um get like the number when you're doing this. Okay, U64 from th minus similar. The overall design I think is the same, but like the question is like, do you do it over iterators or for loops? So this one is through for loops. Mine is through iterators. I suspect uh, because you don't have to do as much parsing here or as much collecting, this solution's almost certainly faster, right? Yeah. I have to do a couple collects that I'd like to try and fix. The reality is if like you're going for pure raw speed, like uh you can use iterators, but you just have to make sure that it's like you're not having to collect to like solve lifetime problems. And I haven't figured out how to collect solving lifetime problems, I think is the way. So if there is a way to do that, maybe you can help me. I'd love to see it. Again, like what is that I'm trying to do? Can I have this function return an impl iterator and have this, instead of being a vec usize, be an impl iterator? So this is impl iterator, this is impl iterator, and this is impl iterator, and now I don't have to collect here. Again, it's not necessarily helpful for part 2, but you know. This is I think this is a SIMD problem. I don't know, maybe you all can tell me. I've found like using SIMD to like not always be helpful. A lot of people think like, oh, if I have a vec u8 and I want to like SIMD it to like break things apart or to find, you know, like separating sections, I've kind of found that it's not always helpful. I think over, how do I say this? Even when I was doing the 1 billion row challenge, and maybe I'm just doing SIMD wrong, but using SIMD felt like it took it only netted my solution like 3 to 5%, which maybe if you're trying to eke out the best solution, that does help, right? If you're going for the top of the top of the top, now maybe you use SIMD, but it just didn't help, right? I think my best solution I got down to like right on the order of a second. It wasn't the fastest, like it wasn't in the, I think the fastest was in like the 800 millisecond range, at least on my PC, the fastest Java solution. And my fastest solution was hovering right around a second. And like, I think when I added SIMD to it, it only got me to like 980 milliseconds or something like that. So, I mean, you might argue like, oh, that's cool. I just saved myself 20 milliseconds over the solve. But it turned out not to be as fast. And maybe it's just because, I don't know. Well, let's see. Maybe it's all quite possible I'm using SIMD wrong. But it wasn't clear that it actually helped me. Okay, let's do one more and then it's probably enough for the day. Let's find a rustation. Take while is my friend. 4 lines in, line data lines, columns, push column. Oh, this is cool. You're tracking the column values here. You're going through each of the lines. I mean, I guess this is close to like probably how most people solved it now that I think about it. But for each column, you're going to split the white space, push the column values in there for like that specific column. And then you're going to update your answer with either are you adding or multiplying. Very cool. Take while v does not equal. Okay, so this actually works, but you have to like find where you start to. How do they handle that part? This is going to give you your lines. This is going to give you, for each of the lines, you're going to get the characters. You're not even revving, so I'm trying to understand what's happening. If you're at the end, pushes 0. Oh, you're tracking the values at each column. Man, I'm not seeing how this works. May have to reread that one. This. Nothing fancy, vectorizing. Yeah, like this is what I was saying is I don't know that you necessarily need to have the quote unquote what is the operator or the enum type. Very cool. Okay, I think this was a kind of fun, interesting day. Again, I did mine slightly differently. I think because I was like, oh, can I? Well, here's where it came from, right? Like, to be clear where it came from, I was trying to figure out, like, how do I blockize these things? Like, make them into blocks. For part one, it wasn't, right? Because you can just do blah, 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 do the thing. It was part two, I'm like, how do I make a block? How do I make blocks of it? And um, that kind of led me down the path of, oh, the way that I can block is, I was just, sorry, I blanked out for a second there. It was occurring to me, could I do it another way? But like the thing that I was thinking about is, where is this at? Where is the next operator? And then I can move back from it to solve it. Again, I think the other way is to just look for blank lines, then you can block it out. But as we've seen, I think you could potentially parse it separately both times. Whereas like you just traverse backwards, which I'll try and do for the recap, but you traverse backwards until you get an operator and you've kept these on your stack, and then you solve. And then when you're doing it the other way, you create like iterators over all of these, and then you just like join them together by the values that are there. So okay, I'll refactor. Let's see, and just so you can see how that would look too. This would involve different one. Okay, I'll save that note just so we can maybe see, compare and contrast. If that's the case, then reading right to left does simplify how this works, right? Because you imagine you just kind of keep a stack of like stuff that you need to work on, and then once you get them all, pop them all off the stack and do the thing. Okay, there you go. Day 6 in the bag. I had fun trying it another way. Again, it's probably not optimal, but it does help you. I think it was fun to try and figure out how do I write a generic parser for both parts. Again, it doesn't feel like that's strictly necessary, but it was fun and worth it. So hope you had fun with me. I'd love to see your solutions. Again, we looked at a few already, but if you have your own and I didn't happen to highlight it, send it to me and maybe I'll show it in the next one. So I think that's it for today. Thanks everybody. We'll talk to you later. Bye.